Welcome to this section of the course. We will be solving some rather involved trigonometric equations that have some phase shifts in within the angle bracket. So let's get to it. Alright, as I said, this example has 4 cos theta minus 30. So there's a phase shift inside the angle bracket, and that means that these two angle brackets on the left and right side of the equation are not the same. Therefore, we cannot simply divide sine by cos. That unfortunately doesn't simplify to tan because of the change, change in the phase within the angles. So we have to use our double angle or subtraction angle for cos formula here to simplify the left hand side of this equation. So we will plug in the theta and 30 into this version of the formula here. So this is the subtraction. So we will replace beta with 30 and have theta to be alpha there. So then we end up with this expression here. We'll leave the right hand side of the equation as it is, and we can evaluate cos 30 and sine 30 here on our calculator. We know sine 30 is a half and cos 30 is root 3 over 2. So then we have somewhat simplified our answer, but not quite. So we can further simplify 2 and 4 and this 2 and 4 with each other, and we will have this line here. Then we can, now where do we go from here? We still have cos and sine on the left hand side. We can take the 2 sine from the left and subtract it from the right, so that we'll have all the sines on one side of the equation and all the coses on the other side of the equation. Can you see where I'm going from here? Once we have the sines on one side of the equation and the coses on the other side of the equation, then we can factorize a sine out of the right hand side of this equation, and we end up with this expression. Now we have simply sine theta and cos theta that are factors in these on the left and on the right side of the expression. Now if somehow we can divide and multiply to get sine theta over cos theta, and that will give us tan theta on the right side, and on the left side of the equation we'll get that expression there. Now tan theta can be simply evaluated. We check our calculator, it needs to be in a degree mode because the question wants the answer to be between 0 to 360. We don't have to change the uh, range of values because it's a single multiplier, single theta there. So taking tan inverse of this fraction will give us one of the angles, and we can simply add 180 to 20 degrees because the tan repeats itself every 180 degrees. Our first answer is in the first quadrant, our second answer falls in the third quadrant. So adding 180 to 20.4 will leave us 204. Okay, great. So let's look at the next example here. Here we have cos of 2x and cos of x on the same line. Now this looks like we have three terms, but it's not quite quadratic. And the double angle with the cos means that we have to replace that with either this version or this version or this version of cos. Now, which one do you think is the best? Should we go for sine These two versions have sine involved in them, and the one on the right doesn't have sine involved in it. So I we want our equation to have either be all in terms of x or all in terms of cos or all in terms of sine. I would go for the very right side, the very right version of the formula, because then everything will be in terms of cos and we'll get a quadratic that is in terms of cos. So we'll get this, we replaced cos of 2x here with this bracket here. Now we can multiply out the bracket and collect like terms. So we'll get 6 cos squared minus 3. We can take away 3 from 2 and we'll have a negative 1 at the end of the line. So now it looks like a proper quadratic equation that we can factorize and solve. Now either with your calculator or with a quadratic equation you can solve it or factorize it. So one of the answers will be cos x equal to negative 1/3 and the other one is positive half. And both of these give us valid answers because the absolute value of cos lies between uh, 0 and 1, and both of these absolute values will be correct. So taking the cos inverse of a negative third will give us 109 degrees. And once more, I'll emphasize how that answer comes about, because cos of any angle is the same as cos of 360 minus that angle. So if you take uh, 360 and subtract 109 from it, 109.5, you end up with 250.5. So that's where the second answer comes from. Adding and subtracting 360 will take us out of the range. We don't have to go beyond 0 and 360 degrees because we have x here and x here. That's everything's fine. Taking inverse cos of a half, we'll get 60 degrees, and 360 minus 60 is 300 degrees. Okay, so that's that example done. Let's look at the next example. This example is rather long and involved, so I hope you've taken a break and hold on to your hats here. We've been asked to expand this bracket and show that sine of 3a equals to 3 sine a minus 4 sine cube of a. Now, why? Well, because sine here, 2a and a add up to 3a, right? Okay, but we're gonna take the double angle formula for sine and apply it one stage at a time. We're simply going to take 2a to be one of the angles here. So uh, if you remember, yeah, so this formula is what we're going to use uh, for this question. Okay, so let's see. We're going to replace one of the a's with 2a and the b with single a. Alright, so in this expression we'll have 2a and 2a here, and then we can go ahead and further apply the same formula again. Well, that formula for sine of 2a, and which formula do you think we should take for sine of for cosine of 2a? Well, if you check the right side of this expression here, everything is in terms of sine. So we want to get rid of the cos and apply this formula and to cos of 2a. So in fact we're gonna replace cos 2a with 1 minus 2 lots of sine square of a. So that will help us to get rid of the cos in that on that line on the second term, but we do have here now we have cos A multiplied by cos A. Cos square there can be also replaced with another formula which I showed you in a couple of. If we take uh, this version of the double angle and rearrange it for to get this cos A on this one side of the formula, what we end up with is cos of mm, sorry, my bad. That would still leave us with double cos. So let's see. Uh, we'll have at the minute this cos square here. Now we can replace cos square with just simply 1 minus sine square, my bad. So we we go from there and we multiply out the brackets here and collect like terms, the powers of sine that add up to each other. So multiplying out the bracket, we will get uh, negative 2 2 sine cube with another negative 2 sine cube will leave us with negative 4 sine cube and 3 sine A basically. So that proved that inequality, that identity there. So we answered part A of this question. Part B of this question is to uh, solve this rather menacing looking expression, which is not quadratic, it's a cubic in terms of sine. But we have somehow we have to use this expression here and try to use that to come up with 16 sine cube. Well, we we can slowly build that up. It's fine. We we have negative 4 sine cube, but here we have 16 sine cube. So if we multiply everything by a negative 4 on this expression here, negative uh, or slowly multiplied by uh, well, just replacing a with theta there. Then we multiply by 4 and multiply by negative 1 to change the sign of negative 16 to positive 16. So that's this, and that's that. Basically, we swapped signs because we multiplied by minus 1. And on the right side, on the left side, we got a factor of minus 4 in front of sine 3 theta. So far, we have somehow came up with this expression here. These two expressions are exactly the same. Okay, so all we have to do is subtract 2 root 3 from both sides of this equation here, so that we we get the equation that they've given us. So if we look at this expression is exactly what's equal to 0 here. So we know that these two sides are equivalent to each other. So when the right side is equal to 0, that means the left side will be equal to 0 as well. Therefore, we can now deal with just left side of this equation because there's only a single sine of 3 theta there. So we can start, so rather than solving this box, this blue box here, we're gonna solve this this expression here. Now to solve it, first we can change the signs and take 2/3 to the side and divide by 4. Now we're gonna have to be careful because uh, we were told to use radians in this example here. So we have theta between 0 and 2 pi, but here there is 3 theta. So we multiply up everything by 3. We end up with, there is strict inequality here, and we end up with 6 pi. So we have to uh, find all our answers. We're going to keep adding 2 pi and 2 pi to the first two principal values so that we get uh, it seems that there will be more than two answers. So let's continue that on this slide here. So first we're going to take the inverse sine of negative root 3 over 2, which is negative pi over 3. Now this is already outside the range that we are looking for. We are looking for our answer to be between 0 and 6 pi. So we can simply, what do we do? With sine of any angle, we can say we can keep adding 2 pi to it. That's one, uh, that will give us one of the answers. And the other answer comes from pi minus the angle that we found. Now, we found our angle to be a negative angle, so pi minus theta means pi minus a negative pi over 3. Negative pi over 3, uh, these two negatives will make a positive, therefore that's the same as sine of 4 pi over 3. Okay, so one of the angles here, the first principal value is 4 pi over 3, and when you add 2 pi to negative pi over 3, we can write this 2 pi, uh, the denominator is 3 here, so we can multiply it by 3 and divide it by 3, so we'll have 6 pi minus the pi over 3, which leaves us with 5 pi over 3. So the first two principal values are 4 pi, 4 pi over 3 and 5 pi over 3. Now we can continue and add 2 pi to each of these values. So adding 2 pi means that adding, because the denominator is 3, adding 6 pi to the numerator, so we'll have 10 pi here over 3, 11 pi over 3, again adding another 2 pi to each of these values will leave us with 16 pi over 3, and adding 2 pi to 11 over 3 will give us 17 pi over 3. Now, how sure am I this is still within the range? Because 6 pi, if I think about it, is the same as 18 pi over 3. So all of those values up to 17 pi over 3, pi over 3 are still less than 18 pi over 3. Okay, so these are our answer for 3 theta. We still need to go and find theta. So what do we do here? We have to divide by 3. That means dividing every term on this line here by 3. We'll have 4 pi over 9. We'll have 5 pi over 9. We'll have 10 pi over 9, and so on. You get the pattern. Okay, so let's see. Is there another part